Good afternoon, this is Harry Mellott with Hypertherm. I'm here with Jonathan Murphy from the Light Industrials TNC team. And today we're going to cover a couple of different things. Other than the Powermax 45XP, we're going to be talking about FlushCut, which is a new set of consumables that are coming to market very soon. So you can tell us about that, Jonathan.
Well, thanks, Harry. We're really excited about the new FlushCut process for Powermax systems. For years, we've talked to our customers about different ways we can improve the Powermax capability. And one of the things that we've heard a lot of is the need to be able to cut closer. We talk to a lot of customers that deal with attachments that they need to remove for heavy material handling. We talk to customers that have rusty bolts that are really hard to remove without damaging work pieces. We've talked to structural steel companies that want to be able to cut flanges much closer than they are today to eliminate grinding. And really, that's one of the themes that we heard throughout talking to our customers, is that they really want to be able to cut closer in order to eliminate the amount of grinding that they're doing. For those of us in the industrial community, we all know grinding can be a very painful and time-consuming process. So the thought of our customer base was, if we can cut closer to the base material, leaving less material behind, there's less to grind and more time saved for more valuable activity. So one of the things that we wanted to do was really show you how cutting closer can really save time. So what we ended up doing was some testing in our lab recently, and what we found out is that depending on how close you cut an attachment, it can really dictate the amount of time that you have to spend on the back end grinding. So what we did in our study to understand the value of cutting close is we took a couple of common work pieces. We took one 2-inch lug that was 2 inches thick and 6 inches long, and we took another one, same size, and we did a removal. What we found is that when we removed the 2-inch lug with plasma, we were actually able to do that much quicker than we were removing the same 2-inch lug with oxy-fuel. Now, the graph you're looking at really shows the total process time in each of these stacks. And within those stacks, there are a couple different factors that make up the time to remove an attachment. So you can see the blue consists of the amount of time it takes to cut the attachment. The red accounts for the amount of time it takes to grind the leftover material. And then the green accounts for the amount of time it takes to set up the machine to do the work. So as you can see, the far left-hand graph represents plasma. And the plasma process, from a cutting standpoint, took slightly longer because it was thicker material than the oxy-fuel process. But if you look at the oxy-fuel graph, there was a lot more time spent with setting up the machine. So that's preheating, that's purging gas, that's setting gas, all factors that you don't have to consider with plasma. The next thing that you see here that's really interesting is this big red bar. Because the plasma with FlushCut is able to cut closer to the base, even though it's cut slightly slower, they leave much less material behind than oxy-fuel does, because oxy-fuel has to cut higher to avoid adding heat into the workpiece. The additional material that's left behind takes a long time to grind. So if you're looking at the total process time to remove an attachment, a lug, or a pad eye, what you can see is by using FlushCut and removing more material up front, you're about 60% faster with the overall process than you would be if you were using oxy-fuel to remove the same attachment, lug, or pad eye. And really, what you're seeing, this is an outcome of reducing the amount of grinding. So again, close cutting or flush cutting reduces in less grinding, which reduces overall process time. So we really wanted to, hit that point home and let you know that that's what a lot of our customers were considering or thinking when they told us that they wanted to cut closer. So when we thought about cutting closer, one of the things that we had to do was look at the geometry of our existing torch today. And we actually have a nice diagram up here which shows some of the limitations when you go to cut close with a standard plasma torch or a standard set of plasma consumables. So what you see here in the diagram is an attachment or a lug, whatever you want to envision it as, and then you see the standard plasma set of consumables on a regular torch. Now what you're noticing is two potentially bad things can happen when you attempt to cut close with a standard set of consumables and plasma. The first thing that you see in this example is that when you try and get as close as possible with the geometry, you're actually digging into the base plate. For those of you who work in the shipping industry or heavy equipment, Anytime you dig into the base plate, that's going to cause the need for time-consuming and sometimes very costly repair. I was actually with a customer a few months ago. They had some arc flashing that got into the workpiece, and it was actually a $50,000 repair for one flash. So you can't emphasize the value of avoiding digging into the workpiece when you're cutting close. So you can see the existing plasma torch or standard consumables really lend themselves to that digging motion. The second option that you would have with a standard plasma torch to remove this would be to cut up here. Now, if I were to cut up here, there are two potentially bad things that happen. Thinking about our graph earlier, if I cut here, I'm going to have a lot more material that I need to grind down before I can replace a lug or move the workpiece through the process. So by cutting here, I'm going to be essentially increasing the amount of time I need to spend grinding. The other thing I'm doing is, in some cases, this hook or pad eye can be a very expensive piece of material. In most cases, customers would like to use that pad eye or that hook on another workpiece and save the cost of having to purchase the hook or the pad eye. If I cut here with standard plasma or an oxy-fuel torch, I'm not going to be able to reuse this pad eye or this hook. If I can cut lower and I can cut flat, there's more likelihood that I'm going to be able to reuse that attachment or lug. And customers that use a lot of lugs or attachments throughout their build process see some huge material savings options coming from that. So really, the two shortcomings with standard plasma are A, it can dig into the base metal if you try and get too close, and B, if you cut too high, it's going to leave excessive grinding and it's going to render the workpiece useless.
So it'll take a lot more time.
And it will take a lot more time. So that's where FlushCut process comes into play. We challenged our engineers by looking at this drawing to say, how can we make a process or a new torch set of consumables that will really put that arc in this location. So what we've done is we would essentially need to bend the plasma arc to do that. And to our delight, our engineers, after multiple years of testing and working, the patent process have developed a set of consumables which essentially bends the plasma arc. So the consumables that I'm holding here are known as FlushCut. They were just released this past September. And as you can see, the FlushCut nozzle shield looks very different than any nozzle shield you've seen before. The plasma arc is no longer coming out at 180 degree orientation. It's now coming out at a 45 degree orientation. You'll also notice that there's a flat on the back of this nozzle shield assembly. If you place this nozzle shield assembly flat, what you'll notice is that plasma bore is now facing flush, or it's parallel to the base plate, placing the plasma arc in the ideal location. So what I'd like to do to kind of highlight this point is go back over to our graphics. And what we've done here is we've actually done a diagram that shows where FlushCut is in terms of arc delivery versus where a standard plasma torch would be for arc delivery. So as you can see, again, this is the best case scenario for a standard plasma torch. You're going to have an angled cut, there's a chance that you may dig in, and you're going to have all this additional material between this yellow line and this yellow line that you need to grind. And as we all know, grinding is dangerous, it's dirty, and it's expensive when you start considering labor. With FlushCut, now I've got a nice flat that keeps my torch in the proper location against the base plate. I'm now delivering the arc at a 45 degree angle at the lowest point possible into the workpiece, which is reducing all that grinding. The other thing I'm doing is I'm also cutting lower on this attachment, and let's say this is a $250 lug that I'm removing now. I'm going to be able to use this $250 lug again because the majority of the material is still intact and I have a nice flat base for rewelding. So you can see that the geometry really has got two benefits. The first is the 45 degree nozzle bore that allows the arc to come nice and flat parallel to the plate. And then the second geometry feature is the nozzle or the shield flat here, which acts as a guiding tool when you're cutting. So really, some really novel work went into creating the FlushCut consumables. Again, we're really the first company that's been able to successfully bend a plasma arc. And for those of you who are really close to the technology, you can only imagine the challenges and trials that we went through to do that. So I want to spend a few minutes now talking about how to assemble the consumables. They are a little different, so I'll go over the assembly process for you and show you what parts you need to actually flush cut with a Powermax system. And then from there, we've got 3 really cool work pieces. Again, the product's been out in the field since September. We have a number of customers using the flush cutting process in different ways. 3 of the more unique ways we've seen are flange removal in the industrial or structural steel industry. So we're going to show you some I-beam flange removal. Then the most popular application we've seen is the removal of pad eyes and lugs. So we actually have a couple of lugs and pad eyes that we're going to show a removal for you. And then we're also going to show you how we can wash residual material when we're removing a pad eye by using the flush cutting process. And finally, we have a number of customers that are using flush cut for bolt removal. So we've got a series of bolts set up, and I want to show you how nice and easy it is to do a bolt removal with flush cut. So I'm going to step back over to the assembly area. And again, I really want to cover the different consumables that come with the flush cut stack up and talk about assembly.
Well, just a second. We welcome your questions via Facebook, so please post them on the site, and we'll get to those in a minute. It's pretty amazing stuff, so I'm looking forward to seeing it in action.
Yeah, thanks, Harry. Again, we really think this is adding a lot of additional capability to Powermax, and customers that traditionally haven't used plasma in the past will hopefully be able to use the flush cut process and entwine plasma cutting into their operation.
So you said for Powermax, but what range of Powermax systems are we talking about?
Great question. So the flush cut consumables that I have here are a single set, and this will work from 65 amps all the way up to 105 amps. So when you look at the product line of Powermax systems, right now you can use flush cut on the Powermax 65, the Powermax 85, and the Powermax 105.
And how about the 45 XP?
Unfortunately, because we're bending the plasma arc, the 45 XP just doesn't have enough power to really reliably bend the arc and make our customers feel comfortable with the process.
And cut through thicker material, which is common in this kind of application, right?
Exactly. We're seeing very few lugs that are actually under 1/2 inch or 1/4 inch. So in most cases, it does require the heavier duty system with more output.
Okay, good.
But we are looking, certainly at flush cut options for different systems. So, certainly stay tuned if you have one of the systems outside of the 65, 85, or 105. I'd like to say that we are looking at flush cut technologies for different systems right now as well. So, with that said, again, the set of consumables that I'm going to show you here work with any of our Duramax torches that go with the Powermax 65, 85, and 105. I have had a number of customers ask me, I have an older Powermax system with a Duramax retrofit torch. Can I use flush cut consumables on that? Unfortunately, no. The flush cut consumables only work with the Powermax 65, 85, and 105 for now. So, when you go to assemble your consumables, there are a couple of different considerations that you want to think about. The first thing that you want to do before you change consumables always, regardless of what consumable you're using, is you want to make sure the power supply is off. So I'm just going to go over to my Powermax 105 and make sure I'm off. I'm going to go ahead and I'm going to remove my standard consumable set. So again, these are the consumables that you probably have at home if you own a Powermax. And what I'm going to do is I'm now going to assemble the flush cut consumables. So again, I mentioned there are a couple of unique pieces. The one piece that's not unique for flush cut is the spring electrode. This is your standard 220842 spring electrode that you would use with any of the Powermax 65, 85, or 105 systems. Now, every other part that I'm going to show you is unique to flush cut. So after I've got my electrode, the next thing I'm going to do is I'm going to take my swirl ring. The swirl ring for flush cut is unique. It does have a ridge around the edge that you can touch, feel, see to help differentiate this flush cut swirl ring from the standard swirl ring. So I'm going to go ahead and I'm going to place the electrode inside my swirl ring. Then the next thing I'm going to look at is my 2-piece retaining cap. Now this is a completely new retaining cap design that we've never really worked with before. It has 2 pieces. The reason it has 2 pieces is this outer sleeve actually engages with the cap sensor switch in the torch. What that does is it tells the torch when the engagement's in place, it's okay to have power coming into the torch. When that torch cap sensor switch is not engaged, no power can come into the torch. I'll explain why that's important in just a minute. But when you are using a cap or you're putting a cap on, we do require that you check this cap to make sure that it can go up and down. If this cap can't move freely, it won't engage with the cap sensor switch correctly, and the cap needs to be replaced. So again, up and down on the cap, you're good. If the cap doesn't go up and down, it needs to be replaced. So I'm going to go ahead and place the retaining cap and the swirl ring and electrode onto the torch. I'm going to mate it. And what you're seeing right now is there's a gap area between that outer sleeve and the torch. There's no cap sensor switch engagement. Now, a special consideration when you're using FlushCut is you need to think about the nozzle orientation. The nozzle bore is off-centered, so you need to figure out what direction you want this nozzle bore to face for your cutting purposes. For me, I'm going to start out cutting a couple of lugs, and the way I like to cut is I like, if the lug is in front of me, to pull this way. So for that purpose, I know I need my nozzle bore to be facing in this direction. So I'm going to go ahead and snugly place the nozzle shield assembly on to the electrode. This nozzle shield assembly is a single saleable piece. Typically we sell our shields and our nozzles separately. We've combined the nozzle and shield for FlushCut, so you will purchase them as a standard stack up. And that part number is going to be 420533. Now that I've got it in place, this is the next critical step. This is a retaining ring. This is part number 420540. It's unique to FlushCut. And what it does is it holds the nozzle bore in place. And the other thing that it will do is once I start to twist it, it's actually going to coincide with the two-piece retaining cap. And what you're seeing is that retaining cap is now engaging with the cap sensor switch, which tells the system it's okay to turn the power on and it can go into the torch. So again, one thing that we want to ensure with FlushCut consumables when you're building the stack up, you want to make sure that this is on very tight. If you don't have the retaining ring on tightly, there's a chance that you could get a torch stuck open error or 0.30 error. If you see that, you want to go back and tighten your consumables because chances are they're not as tight as they need to be. So that is our basic assembly steps. One thing I do want to point out, again, this nozzle is going to need to change direction. So I may be cutting this way now, but later on I might need to cut attachment this way. If that was the case, my nozzle bore is now in the wrong location. So for me, what I need to do is I need to change this nozzle bore location. So again, I'm changing consumables, I'm going back to my power supply, I'm going to turn it off. Always turn your power supply off. Now that it's off, I'm going to turn my brass retaining ring. My cap sensor switch is going to disengage from the cap itself. I'm going to take my nozzle off and I'm going to place it snugly in the opposite direction. I'm going to put the retaining ring back on. And as we're doing that, what you'll see is there's going to be engagement again. It's nice and firm on there. And I'm going to go back, I'm going to turn my power supply on, and now I'm ready to do some flush cutting. So,
before we get over to the table and do some flush cutting, we do have a question from Alberto. He's wondering if you can use those consumables in a CNC for bevel cutting.
You certainly can. Again, it's got a unique geometry to it. The FlushCut consumables do work well on track burners, so depending on how you wanted to orient your track burner in relation to the nozzle bore, that's certainly a possibility. We have had a couple of customers in structural steel actually do some light beveling by hand because of the angularity. Really not what the torch was intended to do, but it certainly has been a nice byproduct for some customers.
Great. And again, if you're just joining us, we're here with Jonathan Murphy. He's talking about FlushCut consumables, how they operate on the 65 through 105 Powermax systems. And I think we're all set. We're going to go over and actually show these new consumables in use flush cutting lugs.
Yeah, we're going to go over and cut a couple of lugs, and then for those interested in structural steel, we've got a nice I-beam section that we're going to cut the flange with, and then finally we've got some bolt hole removals.
So go ahead and keep your questions coming in, and we'll get some.
We're going to go over and set up the system.
Power on when you're ready.
Okay, yes sir. And we want to make sure that that retaining ring is nice and tight. We're going to be cutting at 105 amps with the Powermax 105 today. One thing I do highly recommend is never cut corners with safety. I know a lot of our customers will wear eyeglasses instead of full masks when they're plasma cutting. With FlushCut, the arc is staying on top of the plate. It's really important that you wear a full face shield and full protection, because what will happen is you'll get a lot of UV rays back at you and you will get a skin burn. So again, we strongly recommend wearing a mask when you're doing flush cutting.
So this is like a shade 10 or higher?
I'm going shade 8 right now. So, as you can see, we've got a couple of lugs here. This is a really common application for a lot of our customers. Probably the most common for flush cut. And what we want to focus on is, again, getting as close as we can to the base plate without digging in. So what I'm going to do is I'm actually just going to make sure that my cut area is clean and free of debris. That's going to make cutting a little bit easier for us. The other thing I want to make sure that I'm doing, when I start the flush cutting process, I'm actually going to do an edge start. And what the edge start does is it prevents a lot of blowback from getting in between the nozzle bore and the shield, and that helps to extend the life of the consumables. So again, I'm going to do this removal at 105 amps. During the cutting, I'm going to maintain about a 1/4 inch or a 6 millimeter standoff. We made some pretty quick work of that lug. That's probably about a 1/2 inch piece. One thing that we want you to consider when you're talking about thickness with lugs is the weld bead. So the cut capacity for flush cut is the same as it is for standard plasma systems. The 105 was capable of getting through a full inch to 1.25 inches, or again 24 to 35 millimeters is comfortable for that. But when you're thinking about the thickness, you need to consider the thickness of the weld bead in addition to the lug. So that's a conversation you want to have with your customer. Now, as you can see here, there is a little bit of slag that will come off very easily as it cools down. You've also got a little bit of residual material. What most customers tell us is today they're not able to get in under a 1/4 inch residual material left. We're able right now to have about 1/8 of an inch to 3/16 of an inch of material left on the plate. That should save minutes to potentially hours, depending on the number of lugs you have in an operation. One of the really neat things about this is it's very easy to clean up. So again, the slag on this will come off very easy. Just going to knock some of this slag off. The next thing I can do is I can actually reduce the amperage. Again, I did this cutting at 105 amps, but rather than going to get a grinder now, I'm actually going to use FlushCut at a lower amperage. I'm going to turn my amperage, or have Harry turn my amperage down to about 70 amps. And all I'm going to do is I'm going to place the torch in the same location, and I'm going to move it back and forth lightly. And what you'll notice is I'm actually blowing more of the slag out, and I'm getting some more of this residual material removed. Harry put the consumables in gouging mode. The other thing that we can do, just to get a little bit more arc stability at lower amperages now that I've removed most of the material, is I'm just going to place the system in gouging mode. That's going to allow me to have a little bit more ability to transfer the arc now that we've really reduced the amount of material on the plate. What you're looking at now is primarily slag. So again, I'm going to cool the slag down, and then we can take a look at that plate in a few minutes. So again, I can reduce my amperage even more, but in most cases, that's going to be a lot lower than you're ever going to get with an oxy-fuel torch or a standard plasma torch, and most people would be very happy to grind off that little amount of material that's left behind.
Very nicely done, John.
Thanks, Eric.
So you get a huge time savings using FlushCut over oxy-fuel. Less grinding. You're able to reuse the material, the lug, again, because you're cutting it so close to the plate. Other benefits is cost. When you're doing a lot of grinding, there's a lot of cost involved into that. And obviously, maybe not obviously, but there are injuries associated with grinding. When discs shatter and sparks are flying, things can happen. So we're at 30 minutes in the presentation. Again, thank you for those who are joining us. We're demonstrating FlushCut consumables, new consumables launched in September of this year that are available for the Powermax 65, 85, and 105 systems. So you want to demonstrate for us lug removal or washing out bolts?
Yeah. If we have a few minutes, what I was going to do is
on the ID.
Well, let's get the bolts over. This is a really common application. I actually just spoke with one of our mining customers. They have some equipment that have some really rusty bolts that require regular maintenance. So they actually were spending a lot of time, as you can imagine, grinding lugs, the activity that no one really wants to get involved with, grinding. And what we said is, well, try our FlushCut consumables. It won't damage your material that's left behind, and we think you should be able to remove those lugs, or those bolts, got lugs on the brain, a heck of a lot faster. So what I've done is I've set up a plate here with a couple of different bolts, and what I wanted to do is just show you how easily I'm going to use FlushCut to remove these bolts. So again, I've got some smaller bolts here. I'm going to use a reduced amperage. I'm going to cut or remove these at about 70 amps. And what I want you to do, it may be fairly difficult to see. I know we don't have a professional camera in-house today, but I want you to see how quickly we can drop these lugs. The other thing I wanted to point out was that we really, again, are going to not damage this nice, shiny base plate.
So let me adjust it to 70 amps. Turn on your blower or air extractor. Is that 70 amps?
Yes, please.
Gouging or cutting?
Cutting, please.
All right, you're good to go.
So again, all I'm going to do is I'm going to really use that guiding flat here, and I'm going to line it up against the edge, and I'm just going to literally pull it. And what should happen is I should be dropping this bolt. So. There's one. Rusty bolt, new bolt, any bolt, flush cut, really no problem. You can see that was really quick. Again, we see very little damage to the base plate because it is such a quick process. There's no warping, and we got those bolts up pretty quick. So if you'd rather do that than sit there with a grinder and grind those off, it's certainly an option. Again, I was doing that at 70 amps. I could have probably done that as low as 65 amps if I needed to. So we're going to do one more quick application for you all if you've got time.
Getting pretty close, but yeah, we'd like to see you do what they call a rat hole on a I-beam.
Yeah, yep. Flange removal is a really common need for our customers. So I'll help Harry with that. That's a very heavy piece. Now, when we talk with our structural steel customers, one thing we know is important to them is being able to cut this flange when they're doing construction. And what they're doing is they're cutting the flange so they can create a rat hole, which is an opening for them to actually be able to go back in and weld the material together. In talking with our structural steel customers, we know that it's really critical that they cut this flange as flush as possible to prevent any arc striking that would actually render the piece useless. So again, it's a really critical operation, and the more flush you can get the piece cut, the less likely you are to have costly repairs or rework. So again, this is a larger piece. I want to make sure that I've got the right ergonomics set up for the duration of my cut. So I'm just going to do a nice dry run. I can see I'm going to get a little tight with my cutting booth there. So I'm just going to move it a little bit. Do another dry run. I feel much better about that. So I think we're set to go. I'm going to have Harry turn my system up to 105 amps. We're going to do the amp removal at full amperage. The other thing I would like to, put in the back of your mind is these torches can also be used with Duramax robotic torches. So if you were doing flange removal with a robot and you'd like to see if you could try flush cut with your robot, this is another consideration. Again, you don't have as much turn radius because of the angularity of and the nozzle bore direction. So here we go. Harry, is that set? Okay. Got a nice smooth edge right there. If you were coming in here with your welder, you'd be really hard pressed to have any issues with hitting flashing because, again, we're almost flush with that webbing within the flange there. So again, we really think there's a lot of opportunity for our structural steel customers to take advantage of the flush cutting process and reduce grinding and make their rat holes a little bit safer and better for everyone.
So with a variety of torches, obviously it makes the job easier as well, because you can put it on a 15-degree Duramax torch, a 75-degree like Jonathan has been using, mechanized torch for mechanized cutting, even beveling as we had been asked earlier. So great demonstration, Jonathan. Encourage everybody, if you're going to FabTech, stop by our booth at FabTech. Try these out. We're going to have them in the booth. You can do some cutting, flush cutting yourself. If you bought a Powermax 45 XP recently, we thank you for your purchase, as well as check out our Facebook page. We do have a unboxing contest. So go there, enter your video, and have a chance to win some great prizes.
Well, thanks again, Harry.
Yeah, thank you, Jonathan, and thank you for watching. Again, if you have any questions even after this event, please post them and we'll get right back to you. Again, appreciate it. Have a great day.